let's play Security Jeopardy. All right? We have some of the foremost experts in AI security here today. And so we're going to discuss, and it's actually, in all seriousness, we're going to have some fun, but one of the biggest concerns of businesses is, and just individuals, is adopting AI because of security. Is, should I put my information in there? Is it going to, turn into the Terminator and come for me? There's all sorts of things that we considerations, and we're fortunate enough to have this team. So we're going to play this game show style. So, contestant number 1, could you please introduce yourself?
Hi, everyone. Am I hot?
You're not bad looking.
Okay, I can hear my mic. All right, good. Thank you for saving the coveted spot of the entire conference for us. I know that your confidence in our ability to anchor the conference in the last spot is what made you select all of us for the last spot. So thank you for the conference. I'm Fulkerson. I'm the CEO of Opaque. Opaque is a company that was founded by the directors of the UC Berkeley's RISE Lab, now known as the Sky Lab. These are the same people who gave us Spark and Ray, and these are foundational AI technologies. They created Opaque with the expectation that companies and organizations would need to use their proprietary data in their AI workloads, and they would require guarantees that their data didn't leak. So they built a software stack that allows you to do what we call confidential AI.
Thank you, contestant number 1. Contestant number 2, please introduce yourself.
Hi, I'm Katherine Druckman. I am an open source security evangelist at Intel. I have a lot of things. I also am involved in several open source communities, among them the Open Platform for Enterprise AI, where I lead the security culture. And I also co-chair developer relations and marketing for OpenSSF, the Open Source Security Foundation. I'd love to see all of you join me in any of these efforts. I also like long
Thank you, contestant number 2. Contestant number 3.
Contestant number 2 just stole my joke, so I have to re-say that. My name is Nathaniel McCallum. I'm a confidential computing fellow at AMD, and I've been working in the security, cryptography, privacy space for longer than I like to count. So.
Thank you, contestant number 3. Actually, funny side note, Nathaniel and I worked together 20 years ago, and we lost contact, but we used to go on the road together selling open source software, free software. It's not an easy gig.
And now we take long walks on the beach.
Now we take long walks on the beach. All right. Last but not least, contestant number 4.
Okay, hello everyone. My name is Pankaj Telang. I am a research scientist for a startup called Stacklok, which is a company founded by founders of Kubernetes, Craig McCallum, if you heard of that name, as well as Luke Hines, who is inventor of Six Store project. So happy to be here and looking forward to this.
All right. Contestant number 3. What is the biggest threat that we face today in security and AI?
The biggest threat that we face is the massive list of assumptions that we make about our security and our privacy, and we are not explicit about them. So that means we're not able to reason about the way in which we make these security assumptions, right? So if I am given, for example, some kind of authentication and I hand you a secret to decrypt some data, I've just given you that secret. How long does that secret live? What code gets to see it, right? Who has access to it? Is it going to sit on disk somewhere? This is, if you consider this as a broad category of software, there was a broad category of vulnerabilities. There was a IBM Cloud report that went out a couple of years ago, and something like 70% of all cloud vulnerabilities fit into this bucket, right? So it is a massive, massive list of vulnerabilities.
All right. Contestant number 2. How important is open source in generative AI security?
Well, I'm a little biased because I've been an open source person for a very long time. But my take is that to solve these problems, we need to collaborate. So openness is the road to that collaboration. We need to solve the very difficult problems together. I love what Nathaniel just said. We take a lot of things for granted. And I think, especially when we're in this rapidly evolving field, we're all super excited, right? We've got to get our proof of concept out. We've got to get our minimum viable product out. We've got to get it done, make it cool, make it glossy. And I think too frequently we forget the important fundamentals. We need to take a step back and just remember, what is the threat model of this thing, right? And keeping that at the forefront of the conversation is so critically important because of the impact that the types of applications we're talking about will have and continue to have on our lives.
That sounds like a winning answer. Contestant number 4, if you had to give advice to anyone who was looking at their security posture for their business today for Gen AI, where would you ask them to start?
Yeah, so my focus has been more on the security and privacy of the code that is generated using AI-based systems. So there are several aspects that we need to consider when we are using AI for generating code. For example, is the generated code safe to use? Is it making use of malicious dependencies? The LLM that is used for generating code has a knowledge cutoff date. So if you make use of an LLM for generating code, it will not be aware of the malicious packages. It will not be aware of the CVEs that have been found since the model was released. So you need additional systems on top of just using a plain LLM for code generation. So, my answer is very specific, but, hopefully.
And very good. That's a winner, too. Contestant number 1. There's a lot of privacy-preserving techniques that businesses use today, and they were put in place before the age of generative AI. Which of these techniques are probably no longer as effective as we thought when we put them in place?
So this is a softball, which is every enterprise uses a variety of anonymization techniques on their data when they go to operationalize it. You'll know it as masking, hashing, pseudo-anonymization, tokenization. These techniques that scramble the data have some consequences with the data losing its fidelity or some level of fidelity, which hurts the AI insights. But the bigger issue with this technique is it's actually not privacy preserving with LLMs, because LLMs are really good at pattern recognition. So you can take data that's been masked, you can put it into an LLM, maybe you need some auxiliary data, and it will re-identify the data. It's called a re-identification attack. So that's the practice that I think Mark was teeing up. However, I would add that there was a time when we only had encryption at rest. Everybody would encrypt their data at rest. And people would merrily exchange credit card information over a network without an SSL cert. We would just use HTTP. That's what the S is in HTTPS, is that is an encrypted channel that folks now use to communicate their credit card information and passwords over the network. I remember going to like OSCON or Linux, whatever the Linux conference was back in the day, and my buddy would sit there with a packet sniffer on the network and look at all of the information going across the network because it was not encrypted channels. Everybody uses encryption in transit today. There's one area that organizations have not adopted encryption, and it's encryption in use. So the reason why people have historically used data anonymization techniques is partly because during the processing of the data, they're processing it in the clear. And there are new technologies, confidential computing, that Intel and AMD and ARM and Apple, their new private cloud compute, utilize encryption during compute. So this is what I would say is the most important area to stop processing data in the clear. So I know you were teeing up data masking, but I would say that the bigger issue is stop processing data in the clear.
I wasn't teeing up anything. All right. Actually, that brings me to the bonus round. So a few years ago, we had a security bug in a library called OpenSSH. And the interesting thing, since Aaron brought up SSL, most of the internet uses these libraries, and there was a huge gaping security hole, and it turns out that this open source library was maintained by two people, one of them who was supporting themselves by delivering pizza, and we were putting literally billions of dollars of commerce over this library every day for an extra 5 seconds of attention. What was the name of that bug?
The name of the bug. What was it? Do you guys remember the name of the bug?
Heartbleed?
Heartbleed. So when that came about, I think this is a really important point because it ties together the fact that what Nathaniel said about we take things for granted is we have this library, everyone uses it, we thought it was working, and we didn't pay attention, and all of a sudden, the whole world catches fire because they realize that all this commerce goes across encrypted, but with a huge gaping back door. So
I think a lot more needs to be said about that, actually.
Why don't you go?
We all have soapboxes about this, I'm pretty sure.
Yes.
Like, just
yeah,
back up the truck, bring in the soapbox.
Before you guys jump into the soapbox, I want to strongly recommend Oxide Computer has a great podcast where they interview the fellow who identified the bug, who's a performance engineer who identified it, and they go deep into the details about the social engineering hack that got the person access from China and how this person found it. It's a fascinating story, and that podcast is the best one I've heard. That tears it down.
Totally a cool story, especially because the guy who found it was like, oh, this is like a few microseconds slower than I expected. So why? And he just got curious and started looking to it. Absolutely crazy.
And isn't that the same story as the XZ vulnerability too? It's like, oh, hey, this is a few, those are the real heroes in the world, right? It's those people who pay attention to those tiny little details. Anyway, I'll let you
now you've got
get
your
back to your
soapbox.
soapbox.
Yeah, this goes, I think, exactly what I was saying before about assumptions, right? Like, we make all of these assumptions about the stacks that we are currently using, and we have no real way to quantify that. I was just talking just a second ago, if you buy a head of lettuce and it's got some bacteria on it, the CDC can track that all the way back to the particular field of the particular farm in which that head of lettuce was grown in, right?
They used to be able to track it.
Yeah, yeah. But we need something like this in computing as well, right? We have to start all the way at the software, right? We've got to have like SBOMs all the way up through, and then we've got to stick all this in confidential computing or other forms of attestation where we can track it all at runtime as well, so that at any particular point when we actually have a vulnerability, we can backtrack to all the assumptions that went into this, but they all have to be articulated as what those assumptions actually are, so that we can begin to quantify them and then reason about that. How do we create a policy on that? How do we be able to forensically audit it right when it goes really badly? Yeah, I'm going to let my colleague from Intel actually talk about this as well, because I mean we're both working sort of in the same space with confidential computing, right? Where we can actually begin to have the tools
absolutely.
to put this together.
Adoption of that kind of thing, is complex, and there are lots of reasons, I suppose, why it is not as ubiquitous as we would like to see. But actually, I had a different soapbox, and that's about my soapbox is about how we need to support open source maintainers, because at the end of the day, when you're You're talking about critical
clap, because
infrastructure.
people clap.
Yes, thank you.
This is what I was expecting to hear.
Yes,
Absolutely.
this is about supporting open source maintainers because, again, we put tremendous pressure, obligation on people who are working as solo maintainers. If you look at the statistics on how many open source projects are maintained by a single person, not even two people, one single person, it is mind-blowing. Even when you correct for adoption rates, you'd be surprised at how many widely adopted projects are also single maintainer projects. And so this really what this goes back to, and what I would like to see, and what I tend to get a little soapboxy about, is taking ownership of the projects that you rely on. If you are relying on a project, and it goes back to SBOMs, right? Know what's in your software. Know every single thing. And if you rely on any of that, which of course you do if you're producing software, you need to make sure that you're doing the due diligence to not only know what's in it, but support its existence. It's at a very basic level.
This is precisely why I was saying this quantification of the assumptions is so important, right? If we have a tree of like, oh, this is the software that I'm using, this is the source it's built from, and now we can even go into maybe GitHub stats, right, of who are the contributors, and we can identify precisely these problem points where we see, maybe we should send more pizza to Sarah because she's maintaining some really, really important software project. So
She was really busy delivering them, though. She was actually delivering pizzas, though.
Yeah, right.
That was how she was supporting herself. And then if you read like the person who like trolled her, he had multiple sock puppets that were like kind of verbally abusive to her. It was a her, right? Was it a female? I think it was a female. Was the maintainer of it? Whomever the person, they, them. But the fascinating thing was the communication that they directed at the maintainer was not as caustic as other open source communities. It was like, when you read it, you're just like, oh, that's actually not that bad. But it was, because if you're going back to open source maintainers, there's also this like level of kindness that should be directed at them as well.
One hope.
So now I have just gotten AMD and Intel together.
I know.
I have created a superpower.
History-making moment.
But I would also like to get it at a different perspective from someone on the software side. So that's the number 4.
I was just going to add to the discussion that we had. So confidential computing is absolutely important. One of the other things that would be important is differential privacy. So one of the issues with LLMs is leakage of the data on which the models are trained, which is a kind of a bad situation that one can have with LLMs, especially if LLMs are trained on private data. So how do we prevent that? So differential privacy is one of the sort of the key technologies that can be used, by which there can be mathematical guarantees that an LLM will not spit out the training data verbose, no matter what kind of prompt is used or no matter what you do with the weights of the model. Other thing that I wanted to point out is a couple of open source projects that can be used like today for some of these things. So there is model poisoning as well as data poisoning attacks as well as tampering attacks that you must have heard of. So to be able to guard against those, what we need to do is sign the models and sign the data, like cryptographically sign these artifacts. There is a project called Cisco that can be used for this purpose. It's an open source project which allows you to easily sign these artifacts and not have to worry about managing the private keys yourself. Another project is model transparency. Model transparency is a project that will allow you to generate attestations which will be about provenance, like we talked about. We need to know where a model came from, who trained it, what kind of parameters were used, what kind of architecture was used, what kind of data was used. So all of that can be put into an attestation document and cryptographically signed to ensure that it is not tampered with using model transparency. So there are projects that are out there today that can be effectively used to guard against some of the bad things that can happen.
Yeah. So there's one thing that before we go too much farther, is we keep saying confidential computing, and I didn't really know what that was until last year. So do you want the PhD level or do you want the master's level? Because we got Professor McCallum over here, and we've got, TA. Fulkerson.
You are way underselling him.
Yeah, I know.
I think I'm a TA.
He's compared to you, my friend. So you want the PhD or do you want the TA version? PhD? Okay, hold court, sir.
Yeah, so what we basically have to do is we have to find a way to encrypt all the memory in the system, and then we actually only decrypt it once it's actually inside the CPU, right? That's the thing that is going to allow us to actually process data while it's running. And so there's a variety of techniques for this that existed in the industry. It does seem that the industry is kind of settling on confidential VMs as the most common approach to this. And basically it just means that all the memory of the VM when it's running is encrypted all the time, and then when you actually want to run the instructions or gather the data is loaded in ciphertext into the CPU. From there, it's decrypted, inside the CPU, and then actually executed. But there's a second half of this which is incredibly important, which is how do you know what that software is and that you're actually running inside of a privacy preserving system. And this is where the pitch that I kind of like to give is that there's really two halves to this problem. There's the privacy problem, and you need to solve the supply chain issue in order to solve the privacy problem. But then on the other hand, you've got the supply chain problem, but you can only really solve the supply chain problem if you have some guarantees about the confidentiality, right? So both of these are incredibly important problems we have to solve in the industry, and confidential computing is, I think, a very important tool that we can use to extend other benefits like SBOMs, things like efficient software signing with things like SigStore. These tools combined together and integrated in a way that's really healthy will really basically just tie together the system end to end. And this is super important, I think, for the advent of agentic AI, right? Where we've got all of this data flowing, we've got all of these queries happening, right? All this inference happening, all these different places, and we've got to have some way to know end-to-end through this system that we have no data leakage, and we need to be able to reason about that. So I hope that was at least the bachelor's level answer.
I think that was great. I'll add on the topic of agents. If you look at the combinatorial math around agents leaking data, let's assume for a moment that an agent running inside of your enterprise that's accessing a bunch of unstructured data sources has less than a 1% chance of inadvertently sharing the wrong data to the wrong person or egressing it to the wrong place. I'll just round up and say it's 1% for simple math. That one agent maybe has a 1% probability of inappropriately leaking your data, but when you map it to 100 agents using math combinatorically, you're at about 60% probability. When you ramp it up to 1,000 agents interoperating and sharing information, you're at 99% probability that you're going to leak data. So going back to confidential computing, which there's a confidential computing summit, Google it, it's in June. The wonderful characteristics of confidential computing that AMD, NVIDIA, Intel, ARM, all of the major microchip manufacturers, including Apple, have released, is going to the important point you were talking about, signing. You can sign your model so that you have verifiable proof of, is that, which model? What was it trained with? You can have a signature from the hardware so that you can attest and verify that model, or a data connection, for example. There's a great talk on the AI Confidential podcast where I speak with the CTO of Microsoft and the CTO of AMD, where we talk about how you can secure software development lifecycle and also hardware design and manufacturing supply chains using this particular characteristic. You should check it out if this is something that interests you.
Yeah, another technology which is relevant here is federated learning, where when multiple parties, they want to train a model using each other's data, they don't even have to share their private data. They can keep the private data local to them and instead make use of federated learning, where they run the training of the model locally and only exchange the gradient updates with a central server. So that greatly reduces the exposure that these companies might have due to sharing of their private data.
I really hope that's what's coming across, is that all of these pieces work together, right? And we've got to.
These are all composable. They all fit together.
This has to be composable in a way that is efficient and that we can actually attest the composability of the entirety of the system. So.
I was just gonna say, we're all very excited to talk about AI applications, but at the end of the day, applications are still applications, and they have many of the same security concerns. There may be a little bit of added complexity, but at the end of the day, we still have supply chain concerns, and we want to use things like maybe SigStore, OpenSSF project, by the way. and so we want to, you sign a binary, you sign a release, okay, sign a model. It's the exact same concept. You want to build a fence around your application and on the hardware level, that's confidential computing. It's not something specific to AI, but it is the exact same benefit.
Yeah, I was thinking about some of the principles that we learn in cybersecurity 101, defense in depth. That applies to AI-based applications as well. So we have to think about the security of a generative AI application starting from the user interface all the way down to the infrastructure level, just the way we would think about security of any application.
Oh, I'm still here, yeah, good. All right,
question,
now,
please.
Next question. No, this is awesome. Actually, I really think that's what happened was good, it's a holistic thing, is that you can't just say there is a solution. It's a methodology, it's a process, it's an understanding. When you have new technology, the attack face expands, and if you don't even realize, one of the most craziest hacks I've seen was the vision model hack, where the vision model was interpreting, and I forget which model it was, but they were interpreting pictures. Well, they made sure that you wouldn't ingest a harmful training picture and output something that was offensive. But what they didn't think about is somebody would take a picture of an exploit, and when the vision model interpreted the picture and turned it into text, it was an injection attack into the vision model. And so this has never been a concern before, because we had Google Image, which was matching, but we didn't actually process the image. We were just indexing it. So
please analyze this photo of my dear son, Johnny Drop Table.
Yeah, exactly. That's exactly what happened. And then, I think security is for me at least, something that they all have jobs because of my bad practices. I mean, I am just not as strict with things as I should be, but if I was running production infrastructure, I'm like, yes, you're going to get 500 pictures of my dog that I haven't shared on Instagram. That's the stakes. But if you are at a bank, you're at a government entity, you're at a healthcare provider, you have sensitive data. Like this is security should definitely be table stakes. I mean, you should always be thinking about that. So,
or if you're at a high-tech company that services those markets too. So ServiceNow, one of our customers, I used to work at ServiceNow. Their customers are all of the largest enterprises on the planet and government agencies. So they're rolling out all manner of new agents inside of these organizations, and how do you secure those agents to make sure that they're not an attack vector for hackers? They're not going to go after a pilot agent implementation at a startup. They're going to go after, RBC or JP Morgan Chase or the Social Security Office. They're big ServiceNow shops, and ServiceNow is rolling out AI agents as part of their implementation. So for all of you in high tech, you should be thinking about, hey, how do you secure your environments for your downstream customers? And by the way, for me, I'm new to the security space. I'm sure I know Nathaniel and you are old hat in the space. For me, it was when I looked at the potential for AI, I knew that this had the most incredible potential for advancing human progress, but it was really clear that it was going to be through the proprietary data that organizations and companies create real differences is with their proprietary and sensitive data. So for me, it was from the standpoint of like, it wasn't even about security, it was about AI, driving AI adoption responsibly.
So we are in the final Jeopardy. For a free trip, providing you have 2 tickets in the back of your name tag to West End Billiards. Are there any takeaways that you have for the audience?
Yeah, I mean, from my perspective, adoption of AI is a given. So all the organizations will need to adopt AI-based systems and tools to stay competitive in this marketplace. So what we all need to think about are ways in which we can consume the AI-based tools and technologies in the right way. We need to look at the overall picture. So essentially look at it from an end-to-end perspective, identify what are the vulnerabilities at each layer in the end-to-end implementation of a AI-based application, and put in appropriate security controls, both from a technical perspective as well as from a policy and procedure standpoint, to ensure that the AI tools and technologies can be consumed in a safe manner.
I agree. Be rigorously disciplined in your thinking, right? Who's going to get you from where? Walk through every step of it. Take your time, think slowly, and then be aware of the tools that are available to you to help mitigate those problems. It's really the only way forward. Nobody's going to solve this for you, so you have to solve it yourselves, so take responsibility for it.
Security is never done. So as Nathaniel, always think critically as a user, as a business leader, as an engineer, all of those things. Keep thinking about it all the time. It's never done. Maybe it'll get easier, but it's never done. So, and then join an open source group and solve the problems together, get the smartest people in the room, and come hang out with me, please.
Okay.
So, as I mentioned, the only way to differentiate yourself in business or your organization with AI is with your own proprietary data. And I was at an event in San Diego, I guess it was like 6 months ago, and I was speaking with a person who was the chief data officer for a very large music label. This large music label is suing every single one of their distribution partners because their product, being Taylor Swift and other songs, distribute their product through Spotify, Apple Music, Meta. And these distribution partners have merely collected all the data relating to their product, which arguably is their data. They're the distribution partner. But this music label is effectively defunct. They just don't know it yet. They're Kodak. Because why would I sign with this record label instead of Spotify, Apple Music? Why would I give them 50% of my revenue? They don't produce the product anymore. They don't distribute the product anymore. And they don't even have the data to be effective in distributing the product anymore. So the point I'm making here is, as you're thinking through rolling out your AI strategy, really focus on the sovereignty of your data. Once that toothpaste is out of the tube, there is no putting it back in. And it will determine the success or failure of your business over the next, not 10 years, 5 years.
All right. Well, thank you, everyone, for playing today. I think the takeaway is security never takes a vacation, or shouldn't. All right, thanks. This is the last session, but Todd is going to give us the final keynote. And thanks, everyone.